the ventricular system. So what I'm going to do now is show you a different graph. I'm going to draw them eventually side to side so we get a summary of this whole lecture. So the cardiac potential for the ventricular system is different. So we're talking about the ventricles, right? We're talking about the ventricular system right now. Well, remember, the resting membrane potential is often determined by the conductance to potassium and approaches potassium equilibrium potential. Well, this inward current is what brings in positive charges into the cell. We talked about that initially, and that's what depolarizes the membrane potential. That's what depolarizes the membrane potential, and then outward pumping of this current is what causes the positive charge to leak out of the cell, which is going to hyperpolarize the membrane potential. So now let's focus on the ventricular. The ventricular atrial and Purkinje system. Let's take a look at that. So how does the ventricle depolarize? How does the Purkinje system depolarize? They all have the same structure in the action potential. So let's start. Well, both the ventricles, the atrium, the ventricles, right? The atrium and the Purkinje system, they all have the same resting membrane potential, which is around negative 90 millivolts. Well, negative 90 millivolts is closer to what? The resting membrane potential of potassium. So now let's draw out the graph of what the ventricular atrial potential looks like. Start from positive 40, and we're going to go all the way down to negative 100. Negative 100. And we've got 0 up here, positive 20, and let's draw a line. And we've got 20, negative 20, negative 40, negative 60, negative 80. Actually, let's make it much bigger. Negative 80, negative 40, negative 60. Now, we said the resting membrane potential of the ventricles, the atrium, and the Purkinje system approaches potassium. So there are 4 phases. 4 phases. So I'm going to write here on the side of the board the phases of action potential. So the first phase is known as the phase 0. Phase 0. What happens in phase 0 of the action potential? Well, in phase 0, this is known as the upstroke potential. The upstroke potential. So what I'm going to do is start at negative 90. This is negative 90 is where the resting membrane potential of all these cells are. So in order for them to depolarize, they're going to need an ion. Now I'm going to draw it straight up. This depolarization is known as the phase 0. And let's take a look at the cell. Let's draw the cell on the side so you can actually watch this. So this is a cell. And has a channel. So when these ventricles want to depolarize, they need sodium ions. So what I'm going to do is actually, let's use green for the sodium ions. Remember, all the sodium are outside the cell. they can't wait to get in because there's more of them outside the cell compared to inside of the cell. The influx, a lot of sodium now influx inside the cell, which allows the ventricles or the atrium to depolarize, which means a lot of positive ions are floating inside the cell. Can you see that? That is known as the upstroke. Upstroke. So this is influx of sodium ions, right? This is the phase 0 depolarization phase of the ventricles, the Purkinje system, and the atrium. Well, the reason is because the transient increase or the ability of this channel to open up and allow sodium to go in is what allows the cell to actually depolarize. Well, eventually depolarization is going to reach a peak. You can only depolarize for so long. So it goes up, and then it stops. When it peaks, it's going to, because what it's doing is, look at sodium. What is the membrane potential of resting membrane potential of sodium? Well, the resting membrane potential of sodium is positive 65. So what the cell is doing is depolarizing and try to go as close as to the maximum potential it can get, which is the going close to positive 65. So it's going, it's going to go almost close to it. See, we are reaching almost goes to 40. And then it peaks. It's almost close. That's all it needs. Because what it wants to do is it wants to balance the membrane potential of sodium. That is phase 0. Well, then phase 1 is going to begin. Phase 1 of the action potential now is going to be a brief period of repolarization. Like a little brief. What happens when something repolarizes? Something is going outside from the inside of the cell, right? So what will happen is there will be a brief period, so this is depolarization, a brief period of repolarization, and what actually happens is a little bit of calcium, a little bit of potassium is going to leak out of the cell. So some potassium is just going to leak out, a little bit of potassiums, and that is known as initial repolarization caused by an outward current of potassium flowing outside the cell. Well, what actually happens when potassium flows out of the cell, it decreases the ability of this cell to bring in sodium. So potassium goes out, it prevents this sodium channel from keep opening to allow more sodium inside the cell, because now it says stop the depolarization, you've done your job. So what you see in the graph is a little dip that comes down like that. See that? That is phase 1, called initial repolarization of the cell. And then we go to phase 2. Phase 2 now involves the plateau of the action potential. The plateau of the action potential. The plateau of the action potential at this point is caused by this transient increase in calcium conductance, which is going to result in inward flow of calcium. So let's take a look. Now calcium is going to flow into the ventricle. Calcium is going to flow into the ventricles. Well, when calcium flows into the ventricles, you're going to get this plateau graph. That is known as phase 2. Calcium influx. Influx of calcium. This is efflux of potassium. Alright? That is known as the plateau phase. Now, what this is also going to do is during this phase 2, calcium is not going to try to level to come down to plateau the graph. Once that is done, we are now going to move to phase 3. Phase 3 is now repolarization of the cell. Repolarization of the cell. Let's use blue for that. Phase 3 is repolarization. And what happens to repolarizations? Potassium is going to leak out. Potassium is going to leak out. So what happens in phase 3? Well, calcium conductance inside the cell is going to stop. And then potassium conductance is now going to increase. So what happens now is we're going to have this nice channel for potassium to open up. So we did talk about, oh, I'm sorry, I forgot to tell you, draw on the board, calcium influx. So when calcium comes in, you get the plateau. And last but not the least is when you now get the potassium leaving the cells. When potassium leaves the cell now repolarization, efflux of potassium. And that is phase 3 of the cardiac action potential. And once we repolarize, we are now going to go back down. See, as we're going back down, we try to approach -90, which is the resting membrane potassium of rest. Hey, thank you so much for watching the video. I hope you learned a lot. Are you studying for the USMLE Step 1 or Step 2? Are you studying for the NCLEX, or you're currently in nursing school as a nursing student? Are you a PA student currently in school or studying for your PANCE exam? Or are you a nurse practitioner student or trying to take your NP board exam? Listen, I've got super awesome content for you. If you truly love this video and it simplified your learning process, I want you to check out my website below. I've listed all the list of exams, whether you're studying for any of this board exam, and all I want you to do is click on the link right now below so that you can take you directly to my website. For USMLE, just go to smashusmle.com. For NCLEX, go to crushnclex.com. And if you're studying for the PANCE exam, the nurse practitioner exam, or you're studying for your internal medicine board exam, just click below and it'll take you directly to ftplectures.com. Listen, I can't wait to help you. If you need to get in touch with me, just get to my website, be able to reach me directly, and we can work together one-on-one. Listen, you're super awesome, and my goal here is to help your dream come true. If you want to be a doctor, want to be a nurse practitioner, a registered nurse, or physician assistant, I'm here to help you get to that next level with your medical knowledge. Let's save the world together. I love you guys. You guys are super awesome, and do not forget to click on the link below to be able to get to my website. Also, don't forget to subscribe to my channel. You guys have a great day. Let's go.